Hi guys, in this video we are going to take a look at equations of tangent line and how we can use it to get linear approximations of a value of our function at a point that's close to another point. So first, let's recall how to take the partial derivative of a square root. So here we have square root and we got 44 minus 4x squared minus y squared. So one thing you should immediately understand is that you cannot break square root at a minus sign. So I do have sometimes students do this. Like they would just take the square roots and break it apart, and that's just y, and that's just 2x, and so on. No, 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 no. So that doesn't work. You cannot do that. You never, never, never. What you could do is break it at a times or a division, but not at a minus or a plus. So this stands the way it is. Okay, so how do I take the derivative? So what you should know is that square root of a thing, if I wanted to take the derivative of something, that is under the square root, it's going to be 1 over 2 square roots of the same thing and then multiplied by the derivative of the thing. This is called chain rule. So generally speaking, why is derivative of square root 1 over 2 square roots? Because square root is power 1/2. So 1/2 goes down according to the power rule, and then you subtract 1, you get negative 1/2, and that's why this is. But I would just memorize that derivative of square root is 1 over 2 square root. And then because of chain rule, you have to multiply by the derivative of the thing. So what's going to happen? So we're going to get fx. It's going to be 1 over 2 square roots of exactly the same thing as what I had before. So no change. Do not put the derivative under the square root. It never happens. So whatever this is, that's going to be over here on the bottom. And then we want to multiply that by the derivative of the thing, but because this is partial derivative, with respect to x of the thing. Okay, so what is derivative of 44 with respect to x? Well, it's a number, so that's 0. Derivative of 4x squared will be negative 8x. And then derivative of y squared with respect to x, because you are subtracting, it's like a number, because y squared doesn't have an x in it, it'll become a number. And derivative of any number is 0. So this is it. So the only thing you can do is maybe simplify the 8 and the 2, divide by it. But other than that, this is it. So I'll just type that here. And we'll see what's the next step. So the next step is to get the partial with respect to y, but that's the same thing. Again, we get 1 over 2 square root of the thing, exactly the same square root, multiplied by the derivative of whatever is inside. So derivative of 44 again is 0, but so is derivative of 4x squared. It's also 0 because it doesn't have a y. And then derivative of y squared is 2y, so this is what we get. So dividing the 2's, we're just going to wind up with negative y, and then the square root will be on the bottom. Okay, these are our partials. To come up with the equation at a point 1, negative 2, we want to plug in this point. And by the way, why 1, negative 2? Because we are trying to approximate the function at point 9, negative 1.9. So it's no wonder we're trying to get something that's close, that's easy to compute. So you can it's very simple to plug in 1, negative 2. Why is that? Well, because you can check on a calculator, but if you do 44 minus 4, and then instead of x plug 1, and instead of y plug negative 2, but it's squared, so that's really just going to be 2. Okay, it doesn't matter. Okay, so it's going to be 44 minus 4, that's 40, minus 4, 36. And then square root of 36 is just 6, you see? So that's why they're doing this particular point, because at that point, you don't need a calculator to get it. Like, you know what it is. It's just 6. So it's going to be 6 on the bottom, and on the top, it's going to be negative 4 multiplied by x, but that's 1. So you're going to get negative 4 divided by 6, which is the same as negative 2/3. So that's really going to be here. And then over here is going to be negative y, but y is negative 2, so that's going to be positive 2 divided by the 6. So that, I think that's what 1/3, okay? And then once we get that, we can come up with the equation of the actual tangent plane. So how does it look like? So we start with z equal. Now, don't forget that the first term here is the value of the original function at that point 1, negative 2, because sometimes people miss that term. So you have to go back to the original function, plug in 1, negative 2, and we just figured out that that's 6. So this is going to be 6. Then will be minus 2/3. X subtract the x value, which is 1. And then plus 1/3. Y subtract the y value, but because it's negative, it will be a plus 2. Okay, and that's the equation. Now, they are telling us to simplify it. So I guess they just want us to go ahead and distribute. So it'll become, I think it'll become negative 2/3 x plus 1/3 y. And then let's see if we can combine the numbers. So we got 6, add 2/3, and add another 2/3. So that's like 4/3, right? So I think that would be 7 and 1/3, so 22/3, something like that. Hopefully I'm right. Well, we'll check in a second. And it's thinking, okay, we got it. All right, so once you get it, all you have to do is plug in your point, the new point, the one that's close to 1, -2. But don't plug it into the original function. The whole point is to get an approximation. You're not exactly computing it. So you are plugging it into the equation of the tangent line, okay? So let me put the calculator here on the side. So I will just type a function. So negative 2/3 x plus 1/3 y plus 22/3. And I am just plugging that value into this function. And what you are thinking about is, suppose you have a calculator that cannot take square roots. Cannot do anything other than just add, subtract, divide, multiply. You can use that calculator to compute something like that, but you can't compute square roots. So this gives you an approximation of what it is. So this is 6.1. So because we, of course, have all the technology in the world, we can actually define, I'll just call it G or whatever, the original square root and see what the difference is. It should be pretty close, because we just got an approximation. So let's see if I can get that. Well, it's 6.095. So this approximation is not that bad, right?